Very good morning. Hope you are enthusiastic enough now and you are learning also, and you have learned the sufficient details of estimation. Today under Univariate Inferential Statistics we will start another new topic called hypothesis testing. In hypothesis testing, I will discuss about null and alternate hypothesis, then statistics for hypothesis testing, steps for hypothesis testing, and today we will also introduce that hypothesis testing for single population mean. I am sure you will enjoy today's lecture. Let us see the next slide.
Today we will discuss hypothesis testing. So, what is hypothesis? Do you have any idea about hypothesis? If I ask you what is hypothesis? Hypothesis is a statement. Hypothesis is a statement that is yet to be proven. Yet to be proven. Hypothesis is a statement that is yet to be proven. Usually, in statistics, we frame hypothesis concerning the population parameter. Hypothesis for population parameter. So, if you read the history of science, you will find out that n number of hypotheses, there are huge number of hypotheses has been framed by the scientist and proven by experiment or by some other means. So, our hypothesis is limited to the statistical hypothesis testing, and before going into detail of this, let us see the content of today's lecture. We will discuss the hypothesis testing for single population mean, for single population variance, for equality of two population means and equality of two population variances. So, come back to this hypothesis testing, and we have discussed the hypothesis statement that is yet to be proven, and there are we will consider two type of hypothesis. One is H0, which is known as null hypothesis, and another one is H1 which or HA, which is known as alternate hypothesis. Null hypothesis is an assertion about a population parameter, and we believe on it unless it is proven statistically otherwise. And alternative hypothesis is the negation of H0. Alternate hypothesis is negation of H0. Okay. Let us see one example here. The manufacturer of a mobile handset claims that the mean recharge period for the battery of its newly launched mobile set is 7 days, beyond which it has to be recharged. As a busy person traveling frequently, Mr. R found it interesting, but he wanted to assure whether the claim is true or false. So, here our null hypothesis is the mean recharge period is 7 days, which is the population mean. We are basically talking about like this, that null hypothesis mu equal to mu 0. In this case, mu 0 is 7, and alternative hypothesis is that mu not equal to mu 0. That means not equal to 7. And if this is the case, as we told that we will believe on null hypothesis so long we are not able to prove that it is wrong. So, you have to prove it statistically. So, what is then the what are the steps? The steps are identify first your null hypothesis and alternative hypothesis. Then you definitely find out the appropriate sampling statistic, then obtain sampling distribution theta if the statistic is theta when the null hypothesis is true. Please keep in mind, this is very important concept, that when null hypothesis is true, that time you are finding the distribution of theta, that is the sample statistic. What you do? You collect sample, let size n, and you compute the parameter from the sample. And what we are trying to say here, I told that this is what is basically the statistic is theta. Instead of cap, we have given only theta. For example, this theta will be x bar or theta cap, that is x bar, which is basically estimate of mu. Now, this x bar is a random variable, and what you require to know, you require to frame an appropriate statistics. If it is x bar, fine. If it is not x bar, something else, that statistics you find out. For example, when we talk about x bar, we usually frame z, that is x bar minus expected value of x bar by sigma by root n, that we usually frame. Here our null hypothesis is H0 mu equal to mu 0. We all know that expected value of x bar is mu. So, then we write sigma by root n. Now, we have assumed that H0, from H0 we have seen that mu equal to mu 0. So, that means you can write this one mu 0 by sigma by root n, and this is my statistic for which you require to know the distribution. What I said here, that is obtain sampling distribution of theta when H0 is true. So, that means the sampling distribution of the here your x bar, which is nothing but we are converting it into z, and we are writing mu 0 instead of mu, as we are hoping that our null hypothesis is true. And then what you will do, you find out the critical value. What do you mean by critical value? In this case, if it is a z distributed, my distribution will be like this. This is z. Then we want to see that basically this one is z equal to 0. Now, this quantity x bar minus mu 0 by sigma by root n, this quantity follows z distribution, all possible values, all values here, these are possible. If it is sufficiently away from that z, that mean value, z mean value, then we will conclude that mu is not equal to mu 0. So, that is why we will frame critical value in this side, either this may be your, this is your alpha by 2, and or this side sufficiently away, this side, this is your alpha by 2. What we mean to say, if the computed statistics, which one is this one, in this case, if this value falls in the right hand rejection region or left hand rejection region, then we conclude that H0 is rejected, not true. That means H1 is can be accepted, that is mu not equal to mu 0. Then computational, what you will do first, you collect data, that what you have done. In this particular case, what way you will proceed? You will proceed like this, you collect data for x, which will be x1, x2 like xn, then you will compute x bar, which is 1 by n I equal to 1 to n x I. Then you will compute the statistic which we are talking about z, that x bar minus mu 0 by sigma by root n. Now, please remember that sigma will be given. If sigma is not given, then sigma cap will be s, and in that case if n is sufficiently large, then you will be using z distribution like this, x bar minus mu 0 by sigma by root n. So, this is the computed z basically from the data, z computed. Now, you have to choose alpha. So, your next step is choose alpha. You have seen that what is the error you are going to consume. If you say alpha is 0.05, this is also known as probability level of significance. If you say alpha equal to 0.05, then your point will be like this, your rejection region will be like this. So, suppose this one is alpha by 2 and this side this is also alpha by 2, then this is your rejection region. This side this one is rejection region, and in between this is the acceptance region. Okay. So, you have your distribution and you know the that level of error you are trying you will consume, and then what happen, based on this you will find out an interval which is acceptance interval, and beyond it is, as it is a two-tailed case. So, either right hand or left hand, when it goes beyond the critical value, that is z alpha by 2 right hand side and minus z alpha by 2 left hand side, when it goes beyond this you will reject the null hypothesis. So, what you do then? You have already computed z, from table you are getting the z alpha by 2, either it is the mod value you have to take. If z computed is greater than mod of z alpha by 2 absolute value, then what will happen, that either you will come into this side or this side, other way this may be negative also. Okay. So, you do one thing, you just change a little bit, that mod of this also will come under this side. I will take mod in both sides. So, if this one is my 0 value, now if z value is here, this will be positive and this side will be negative, and you will be seeing the alpha value from the z alpha value by 2 value from the table. Usually this one will be a positive value. So, you may not take mod here, no problem. So, the absolute value, if it is more than z alpha by 2, okay, more than or equal you can write. So, that means that what we are saying here, we are saying that if it falls here or it falls here, then it is sufficiently away from the mean value. So, H 0 mu equal to mu 0, that can be rejected. If I reject H 0, that means I am accepting H 1. Okay. Alternatively, I can say that I accept H 0, H 1, not H 0, you are rejecting H 0. So, actually either you will be able to reject H 0 or you will be, suppose your z value comes here, that is within this acceptance zone, then you will say fail to reject H 0, fail to reject H 0. Okay. So, this is the procedure. The procedure says first you must know that what is the problem, and then the appropriate variable you will find out from the population point of view. You collect a sample, from that sample appropriate statistics you generate, then you create the null hypothesis and alternative hypothesis for the population parameter of interest, and then using the statistic as well as its distribution, then you compare the computed value of the statistic and as well as the critical value from the sampling distribution of that statistic. When you compare, if you find out that the computed value is more than the absolute value of that computed statistics is more than the tabulated value, then you will reject null hypothesis. Otherwise, you say fail to reject null hypothesis. Okay. You see this figure, and I know that last class you have also seen the same thing. What we are talking about here, if it is population from normal or non-normal, either sigma known or sigma unknown, and the condition of the sample, that means the size of the sample, whether it is large or small, and depending on this, all of we have seen under interval estimation that your quantity, that statistics may follow Z distribution, may follow T distribution, or you may not get any parametric distribution. So, this one x bar minus mu by sigma by root n, that is for the first case, like second case also same, third case your sigma is replaced by S, fourth case also sigma is replaced by S, but sample size small, that is why it is T distribution. Okay. So, if you use T distribution, what is the same thing? You will calculate the statistic, that is T computed will be your x bar minus mu 0 by S by root n, and then you will be finding out T tabulated. That T tabulated means basically you require to know the degree of freedom n minus 1 and alpha by 2, because T distribution is also a two-tailed distribution and your hypothesis also two-tailed hypothesis. The way you have created hypothesis, you have created hypothesis like this: H 0 mu equal to mu 0 and H 1 mu not equal to mu 0. That means both side is open for you. So, if it goes this side or this side beyond this level, you are not accepting null hypothesis, rejecting the null hypothesis. Okay. So, this is your T distribution and the mean value will be definitely 0. Okay. Here is one important point: when you go for two-tailed distribution, when you go for one-tailed distribution.
So, for mean it should be two-tailed, for variance so chi-square, that should be chi-square is 1, means only positive values are there.
But is it true that for all the time that for mean you will go for two-tailed, or there is something different? Okay. Suppose here in this example we say that recharge period of a battery, that is our example, recharge period. As a user, what you want? You want more the recharge period, it is always better. Now, for recharge period, if you test like this, that H 0 mu equal to mu 0 and H 1 mu not equal to mu 0, suppose your that computed value falls here, Z value or T value, suppose T computed is here. So, now this is the smallest to largest. So, but the manufacturer is claiming that it is here mean value, it is the manufacturer claim. He is saying that this is the mean value. Now, you are testing that whether manufacturer claim is right or wrong. Now, you have collected data and you found that your that t computed or z computed depending on the distribution, it is, in this case we are talking about t distribution, it is falling here. So, null hypothesis is rejected, fine, that means alternative hypothesis is accepted. So, in this case, do you go for the handset? You will not go, because the mean value is much lower than claimed. What will be in your favor? In your favor, if the value lies in other way, that means if the computed value comes here, that is your favorable case. You are rejecting, so long it is in between this, it is nothing but what is the manufacturer claim is there, that is case. If it comes here, this side, it is more than that. So, what you may be interested to create null hypothesis like this, mu greater than mu 0. You may not be interested to test this mu not equal to mu 0, you may be interested to test mu greater than mu 0, means the manufacturer is claiming it is 7 days, fine, 7 days is good, you may be happy, but you are thinking that if it is more than 7 days, that is better. So, in this case, see, it is mu only, but if I go by this two-tailed distribution, your hypothesis for alternate hypothesis, and you cannot by the, you may reject H 0, but it may not go in your favor. So, as a result, what it is said, that it is always better if you do like this. First you understand what is the variable. If suppose x is your random variable, what type of variable it is? Is it lower the better type, or is it higher the better, or it is nominal is the best? Getting me? For example, suppose the sulfur content in steel, percentage sulfur in steel, we do not want that sulfur content, more sulfur content, in fact 0 sulfur. So, it is lower the better. In this case, what you want? Suppose this is the sulfur content. So, ultimately you will be looking for the lower side. So, that means you will create a value that is the maximum value what you want. Your acceptance region, your zone of working will be region will be this. You do not want higher one. Now, if you plot, what will happen? You may find out distribution like this, let it be like this. So, you will go for the left hand side. For the higher case, it will be just reverse. You will fix a value here, somewhere here, and you want this side. Now, you can fix here or somewhere here, but ultimately you see lower the better and higher the better case, means one tailed this test is better. Only when nominal is the best, means there is a target, and if you deviate from the target, if you deviate from this target this side or this side, this is not desirable, then your two tail hypothesis is better. So, for both the cases, this is one tailed and for this two tailed. Getting me? When you frame the hypothesis, null hypothesis, there is absolutely no problem, because from what you are doing, you are basically telling some value for that hypothesis. A statement you are making, it is something like this. Usually we say it is equal to this in statistics, hypothetical testing. But what will be your alternate hypothesis? Now, if you use one tailed hypothesis, what will happen then with for the critical value? Okay. In two-tailed case, you have taken here, suppose this two-tailed case, if I say this is my left side, this is right side, you have taken z alpha by 2 or you have taken t n minus 1 alpha by 2, this side or this side, or here minus z alpha by 2 t minus t n minus 1 alpha by 2. But when it is one tailed, suppose so long it is within this, you are accepting h 0, when it is going this side you are rejecting h 0, then it is one tailed. In that case this will be z alpha if z distribution is applicable, or it will be t n minus 1 alpha. In the other side also, if you think that no, this this one is this left tail only, this also alpha, getting me. So, then this is minus n minus 1 alpha, and here it is, this value is alpha. Now, there is a relationship between this hypothesis and confidence interval. See, if this is alpha, then this side is 100 into 1 minus alpha, that percent, and similarly here what is happening, this is 100 into 1 minus alpha, the interval, that is why alpha by 2 you are making. Okay. So, this is what our hypothesis testing for single population mean. This is one example. Last class we have described. We said that MSD is a problem with industrial workers, particularly the crane operators in heavy industry. Now, a random sample of 76 responses yielded a mean of 7 and standard deviation of 4. Population standard deviation is also given. Conduct hypothesis testing for alpha equal to 0.05. That means, what you require to say that you are basically mu equal to 7, that will be your null hypothesis, and what will be your alternate hypothesis? Your null hypothesis is mu equal to 7 here. Okay, let us see the alternate hypothesis, mu not equal to 7. Okay. Now, here the thing is that as a management point of view, you want to see that no, it is not 7, it is below 7. From operator's point of view, they may say no, not it is not only 7, it is more than 7. The operator who are using the crane, they will be saying that we are suffering more. That the management who are basically maintaining the system, they will be saying no, it is less than 4, less than 7. So, then from which side you are testing the hypothesis, that is also important. Who is who is the owner of this hypothesis in that sense. Okay. And I have given here that what will happen if population standard deviation is not known. You know 76 responses, even if population standard deviation is not known, but sample standard deviation is known, Z distribution will still be applied. What will happen if population standard deviation is not known and n less than 30, T distribution will be, you will be getting the critical value for comparison from T distribution. Are you getting similarity with in confidence interval? There you have created the same way, you created this first you found out the statistic, then in that case what happened in when you have found out some statistics like x bar minus mu by s by root n, then you have created like this minus t alpha by 2 n minus 1 t alpha by 2 here n minus 1, that you have created, and as mu was not known to you, last class we have seen you do not know mu, you created a range for mu. What happened here in this hypothesis testing case, mu is given as mu 0, which is under h 0, and we are saying this particular quantity follows T distribution when h 0 is true. That is why I told you in the beginning that you please keep in mind that whatever statistics you will generate and the statistical sampling distribution you will consider, that is true when edge ray is true. Then now instead of mu you write mu 0, so that means this value you know, entire value you know, and you also know the critical values. This is left side critical values, right side critical values, both values you know. Whether this value is less than this value or this value is more than this value, that you are finding out, and accordingly you are rejecting null hypothesis. And I know how to use Z table, that is very much known to you, T table also.